We want to know when this pair of linear equations has no solution. For two lines in a plane, no solution happens when the lines are parallel but not the same line. Algebraically, that means the ratios of the coefficients match, but the ratio of the constants does not. Let's first rewrite both equations into the standard form. A times r plus b times w equals c. From 6 plus 7, r equals p times w. Move everything to one side to get 7, r minus p times w equals negative 6. From 7, r minus 5p equals 5w plus 11. Bring the terms together to get 7, r minus 5w equals 11 plus 5p. The no solution test is a 1 over a 2 equals b1 over b2, but not equal to c1 over c2. Now, match each equation to the template A, r plus bw equals c. For the first equation, a 1 is 7, b1 is negative p, and c1 is negative 6. For the second equation, a 2 is 7, b2 is negative 5, and c2 is 11 plus 5p. For parallel lines, the ratios of the coefficients must match, so 7 over 7 equals negative p over negative 5. This gives p equals 5. Check that the constants are not in the same ratio. c1 over c2 is negative 6 over 11 plus 5p. When p is 5, that's negative 6 over 36, which is negative 1/6, not equal to 1. So the lines are parallel and distinct, and there is no solution when p equals 5. Let's confirm visually. I'll graph both lines using p equals 5, with w on the horizontal axis and r on the vertical axis. The first line becomes r equals 5 over 7 times w minus 6 over 7. The second line becomes r equals 5 over 7 times w plus 36 over 7. They have the same slope but different intercepts, so they never meet. Key idea to remember: two linear equations in two variables have no solution when their coefficient ratios match, but the constant terms are not in the same ratio. That makes the lines parallel and distinct.